paper is Near Surface Geophysics and Far-Reaching Applications, a recent success story from Chenampalli Fort area, Kurnool district.
Mr. Chairman, sir, and friends, I'm not an engineering geophysicist. I'm an exploration man. But it's a rare opportunity that I have got. I wanted to share with you on this platform of very knowledgeable engineering geoscientists. In fact, I thought any branch of science would grow when there is necessity and when there is demand. Why engineering geophysics is not grown to the extent oil exploration or mineral exploration or for that matter groundwater exploration has happened is probably there is no that demand, that systematic demand, and probably that is the reason why in Geological Survey of India we have not created any specific division to cater to the needs of engineering geophysics. In fact, two case histories that have been carried out by Geological Survey of India come to my mind. One of them is my topic. This is the fort, and both are very peculiar problems. One problem was in a border area. Our neighboring country was trying to infiltrate into our country. Most of you from northern India probably are aware. They were trying to infiltrate into our landmass by digging a tunnel. And geophysical technology, along with other branches of science, were very effectively deployed. And that could be very ably, that problem could be very ably, in the nipping stage itself, it could be solved. This, one of my friends from northern India, he has shared, who has really worked in that heavy secured environment. Very peculiar problem. The other one is topic of my presentation, that is treasure hunting, and government was involved in it. I mean, honestly speaking, I was very reluctant. Why should we be doing any treasure hunting? But then better senses prevailed, and our Director General insisted that we should try and see what can be done, because at a very high level, government of Andhra Pradesh was requesting government of India, and this is a very peculiar problem. In fact, I don't know how far you would appreciate this. That is topic of my presentation. May I have the next slide, please? Yeah, this is in Andhra Pradesh, in Kurnool district. There are a number of forts, ruins. They are all built around 1400 to 1600. End of Krishnadeva Empire, a very strong kingdom during those days, and very rich kingdom, very great heritage, etc. And wherever they ruled, they built number of forts. For some of them for their safety aspects, not for residential purposes. And during the end of that regime, people strongly believed in those areas that a lot of treasure is hidden, concealed in some places, high value, and that has to be, there is a lot of law and order problem. Many people were involved, unlawful elements, very rowdy kind of things, and then people were digging at their own will, etc. And then government of Andhra Pradesh wanted to involve GSI into say categorically whether there is any treasure or not, and tell openly to the public that there is something and there is nothing. Yeah, and that opportunity what we got is my presentation, and the blue line in the right one, what you see is the fort, which is totally in ruins now. Next one, please. Now, geophysics is basically two kinds. One is passive, other is active. That is it is like source and response studies. You energize either not with your intention, like gravity field or magnetic field, and see how the geological units are responding to them. Or The other method is the active method, where you have the control and you can energize the ground and get response out of it and try to convert them into geological units. Both these methods were employed here. In fact, we had no other go. We wanted to find out in an open land, which is highly hilly and very rugged terrain, etc., what anything can be hidden. So what we thought is we wanted to find out where are the weak zones. That was our first line of thought. So we tried to identify any fractures. For that purpose, we did, next slide please. Yeah, for that purpose we did the magnetic survey. And the next one is obviously the high precise GPR surveys to actually locate them. And GPR cannot be done over some 3 square kilometer or 4 square kilometer area. I mean, there has to be some prioritization. Only on prioritized areas you can concentrate these methods. For that purpose, we did, but magnetic survey, what we did is, we did in a continuous mode. That is every 1 meter, 2 meters. Nowadays, you have the facility. You can just walk in a walk mode with a magnetometer. It's like airborne data collection. On surface, you can do with 5 meters. So we did excellent magnetic survey. We filled the entire fort area with a magnetic survey to prioritize where to do the next level of survey. Yeah, and can you go back? The GPR survey, most of you know the principle. It is the in the high frequency ranges this technique is used. It's like any other electromagnetic technique. One advantage is it is not bothered by the nature of the overburden. Resistivity method is constrained by the nature of the overburden, which will either allow or sometimes it doesn't allow the energy to go into to get the information. But GPR doesn't suffer. But only problem GPR is highly localized survey. That is, only the upper layers you get the information about it. Yeah, there is varied frequency ranges. You can choose the frequency in which you want to do. The higher the frequency, the local, the nearer the object. The low frequency of these high frequencies, you can target for something deeper. Anyway, let us say from 0.5 meters to maybe 30 meters, you can get the information from ground penetrating radar. And you can see if there is a boundary, it nicely reflects. It's a very theoretical pictorial diagram. But if there is any void space like the point reflector, what you see in the center, you get a hyperbolic response. So this is how you try to identify whether it is an artificial object or a natural boundary. That's how from the GPR survey you decide what it is in the subsurface. And the frequency ranges, generally what are the other engineering, what are the specific engineering applications you want to target. Depending on that, you choose the frequency. Okay, next one please. Yeah, and this is the electromagnetic spectrum, very well known electromagnetic spectrum. In GPR, we concentrate on the high frequency, ultra high frequency and very high frequency ranges. We choose that energy to energize the ground and get the response. And you know how the energy interacts with the geological medium, and that response is studied and converted into it. Next one, please. Yeah, there are many applications. Now I think it is, the doors are open, many military intelligence, etc. Some strange demands are coming. Accordingly, GPR technique is used. Mainly in Geological Survey of India, we have been using GPR surveys for our Antarctica studies, because in an ice-covered medium to know the subsurface, that is the best method. It applies very effectively and you get the information. Other than the geological applications, yes, there are a number of archaeological investigations that can be addressed. In fact, the more specific is your problem, the better would be your survey design. That's what I felt. Yeah, next one, please. Now, this is the fort. The left one shows more or less the entire picture of that fort, where anything can be hidden. See, it is such an open place, yeah. And we were given this area, and within 1 week we were to identify where could anything be hidden there, what would be our suggestion, etc. And the other right side picture is what people were guided by is a picture of a series of ladies standing there and pointing something, particularly the last two ladies. I don't know whether it is how far it is clear to you, but the last two ladies are showing a finger, and probably people believe that something is hidden there, whatever that finger direction. So they did a lot of excavation there, nothing came out of it. But somehow this is the guiding force for people to believe something is really there, something is really hidden, and that has to be brought out. Yeah, this is it. Another unusual thing is, normally any fort will have bastions in a regular interval, the guarding pillars. And somehow this fort looked to me very odd. I mean, why there are so high density bastions in this, yeah? 2 minutes. 2 minutes? Yes, sir, 2 minutes. Maybe 5 minutes. Why these bastions are there in such a high density? Next one, please. Yeah, this is the picture. This will give you a 360 degrees view of that fort. That is the bastion. And you can see this is the entire terrain is highly rugged, highly open. And I am really amazed that something could be hidden in that area. Yeah, this is how it is. This is the terrain. This is what is given to us. Yeah, may I have the next slide, please? Yeah, this is the how magnetic lines were possible, and those blue lines are the magnetic. Then based on that magnetic investigation, this is the elevation map. The center one is the top of the hill, on either side it is sloping, both north and south it is sloping. And we have, from the magnetic map, we have tried to identify the platforms where there is some gentleness about the slope, where something could be accumulated. Such kind of platforms, 4 platforms we could identify based on the magnetic survey, where there is some thin cover of soil, etc. That is what we could identify. Next one, please. Yeah, those platforms are marked 1, 2, 3, 4, and pictorially this is the platform 4 is not is there in the scene. It is something southwards, further south. Yeah, next one, please. Yeah, then we did the magnetic map. Naturally, magnetic map at such a high density is very noisy. We couldn't really, it was very difficult for us to identify something. Then we applied a filter and we somehow reduced the noise, and we tried to identify a fracture zone. And fracture zone is coinciding with the number of wells they are falling on that line. So we were sure that there is a fracture which is cutting across the fort from that slope to this slope. And in the center, if you can see, yeah, this is the unusual anomaly. Otherwise, there's a low magnetic zone. Somehow we thought, why? We are very confident of our data because it's a high precision data. We have taken a lot of care in collecting the data, and that anomaly, which is highly localized and standing out. Normally, geological anomalies are not like that. So we thought that this anomaly is not a geological region, it is something unusual. So we were almost keen that we should exploit that anomaly and do the next survey. Next one, please. Yeah, this is how GPR survey is done. This is again a pictorial, next one, please. Now, the joints would reflect in a GPR survey like this. Next one, please. And these are the boulders. If they are embedded, they look like this. In the platform, one platform, site 2, we have found out. The second, next one. In the third platform, again, void space, maybe a boulder is embedded in the soil cover, that's how it is doing. Then these are the fractures. Based on our experience, we have tried to convert our GPR signals into possible geological regions. Next one. This is then we narrowed down to this place. This place we thought, between one bastion here and another bastion here, this place I thought was most suitable for something. Yeah, next one, please. Then there, when we conducted the GPR survey, we found out these chambers. So this chamber is exposed. Yeah, and in continuation, not in this picture, in continuation of that, we thought there are some more chambers which are now hidden under soil cover. On the first look, or any amount of surface observation would give you an idea that there is a possibility of a hidden chamber in that particular area. Next one. Yeah, this is the last one, platform 4, where we conducted, and what we got is only joints in that place. Next one. Yeah, this is, then they said, then we said this is our priority one. And the government of AP started doing the operations, and they've opened up, and we have established that this kind of room which is exposed, in the earlier picture nothing is here, we could find out the parallel rooms now covered. Now,